All right, test, test, test. Everything looks good. Alrighty. So, yeah, I'm gonna wait for some people to get in here, and then I'll explain what we're doing today. This is actually an extension of the last time's work. In fact, I am trying to finish this library today, hopefully. So let's see. Anyway, how you guys doing? I don't know if there's anybody in here yet. Let's see. Looks like there's at least one viewer. So how you guys doing? All right. So today I'm trying to finish the difference procedural macro library that I've been writing for the past week or so. I've set it up so that it can do structs, and now I want to make it so that it can do enums too. Of course, let me explain what exactly this code does. So basically, I'm working on a project for IOTA called Identity, and we want to be able to take existing structs and compare two of the same struct, and then find the difference between them and create a intermediate struct, which can then be serialized to and from JSON or whatever format. And then we also want to be able to take that diff and then reapply it to the old struct to make a new struct. And so that's essentially what we're doing here. So if we look at some of these tests, you can see that I've got these test structs built, and they implement the diff trait using the derive macro here. And that allows me to just create the struct, call diff on it, and then merge the diff to then create a new struct. And yeah, so this works for everything from normal structs to tuple structs to unit structs and so on. We can even have generics and larger structs, embedded structs, stuff like that. And of course, now we're going to be working on enums, and so that's what we're going to be doing today, hopefully finishing it too. So thus far, I've actually written a little bit of code for this, mainly just defining the difference enumeration type that gets generated when you derive diff on an enum. So basically what I'm doing here is I'm taking all of the parts of that enum, splitting them into tokens, and then putting them back together in a way so that when you derive diff on the enum, it will then generate a new type. And so the new type structure is kind of in this code here. For instance, right up here, we've got the top part where you'd have like a generic type. In this case, a generic type would be S. And then we want that generic type to implement the diff trait. And then we can have more bounds. So like, for instance, the generic type could implement, say, clone or copy and default and all that stuff. And so the user can add the different trait bounds that they want. And notice the way that this macro is set up. There's a plus sign here, of course, because when you do something like this, like where you have like a where clause, or where you have like a generic, like for instance, say I have an enum here called test, and it has a generic value. Let's just say it has fields in it. The generic value will implement identity diff, and then say I wanted to add clone and then copy and so on. That's essentially what this pattern is. So like with a regular expression, the star at the end basically signifies that there can be 0 or more. And then we've got the bounds variable, and we're using this macro called quote, which allows us to generate the code without actually executing it. And then, of course, we have our plus signs. So essentially, this will create this part here, and then whatever the user inputs into the original type will be appended to the end of it. So that's what that is. And then down here, we've got the actual structure of the new enum. So if the enum is named, we want to be able to take that name and then create this new diff enum. And so that's what we're doing here. So this name here, this variable, is the name of the diff enum. And so it'd be like if we had an enum called test, it'd be called diff test. And then in here, we've got the fields. And so these follow the basic format. So it'll be names and then the type of the name. And it'll just keep doing that over and over and over again. Then we've got a tuple variant where you have the name of the type that's being generated, and then we have the types inside of it because, of course, tuples don't have a name in them. And then we have a unit type where it's just the name. So, all right. And then, of course, all that gets put into a body here where we derive clone, partial EQ default, and then serialize, deserialize, and serialize. And here, again, this is dealing with generics. So if we have a generic parameter, it would come in here and be dealt with. All right. So I know that's not very straightforward, but hopefully that gets you an idea of what we're doing. And so now we're working on a function that will allow us to implement default, or debug rather, on every trait that we, or every enum that we apply the diff trait to by default. So I've already got some of it set up here, so I'm already creating the token stream for the param declarations, which I showed you before. We've got the generic type, and then we're implementing the trait. And then we're dealing with the where clause, if there is a where clause, and we're getting some predicates together. Got a space there. And here's the where clause, by the way, so it's just this format, so the where keyword followed by the predicates. And then, yeah, we'll put together the actual implementation of the debug trait on this new type. All right, let's see. All right, so let's get into this then. Oh yeah, by the way, so the quote macro creates a token stream, and that's basically the way that we manipulate code with our procedural macro. So you'll notice we're taking in this type input model, which is a type that I've created for this library right here. So this could either be an enum or a struct, and then it's got embedded stuff inside of it. But the actual entry point for our proc macro is this function here. And of course it's got this attribute on top of it to define that it'll be diff. So when we derive diff, this function executes, it takes in a token stream, and then it outputs a token stream. And so essentially we're just taking code and we're modifying it, and then we're putting that code back out there. And so that's basically the logic that we're trying to follow here. All right, so hopefully that makes things a little bit clearer as I start to go and work on this. So this function here, it takes in the input model, which has all the different pieces and parts of our enum. And then, yeah, so what I'm essentially doing is I'm taking those parts and I'm putting them back together in a way that will implement the debug trait, at least in this case. And then as we go down, I'll put them together so that they'll be able to implement the diff trait. All right, so I'm going to need 2 vectors. So let's call this one patterns. And this will be a vect of token stream, and let's make it mutable, and then call this one bodies. And then what I want to do is iterate over all of the different variants in our enum and then create cases for that. So Let's see. So for var and I think the variants are just called evariants. I'll iter over that. And then let's see. You know, I actually want to map over this instead. So let's this is basically iterating over it like with the for loop, but I kind of like the map better. So do it like that, just in case I want to be able to use the output of this. So then I want to match on, let's see, so the evariant, let's see, evariant has a bunch of fields in it, and that's what we're looking for. The data fields, or no, first we're looking for the S variant, which is the struct variant of this enum. S variant. So we want to match on that. And then we want to match on, what did I call it in the other one? The name. Oops. And then we also want to match on the fields. All right. So we're doing this as a tuple, make this easier. So then we can say oh, this should just be variant. And then this is var. All right. So then we need to fill in all the cases. Let me do that. So first case will be if we have an S variant with a named type in it. So if we have a named enum variant, then we'll have the name here, and then we'll have the fields. So then we want to take our, let's say these are the field names, and this will be a vect of ident. And identifiers are essentially just the like the types or the names of like variables. So like for instance, the identifier of f names would be f names, or it could be the type depending on what you're looking for. So then I would take fields, let's iter over it. We'll map on this as well. Call it f. And we'll say f.name. I've got a method name, which will give us our name field. And we'll collect these. All right. And then we want to create a buffer. So we'll use the format ident macro for this. I remember, of course, we're implementing the debug trait. Debug uses a buffer to write things. So that's essentially what we're doing here. And we'll create our fields here. This will be a vector of token stream. And we can again use our fields and iterate over them. Let's add the collect part here. I don't know why I can't type today. So anyway, let's say let n equal f.name, and let y equal f.tpy, I think it is, method. Yeah, all right, so that gives us the type. So we get the name, which is the var and then the type for each of the fields. And then we want to check to see if the fields should ignore. So there's I've got an option that the user can add to the proc macro. It can define if they want the diff to ignore a specific field. So we need to check to see if that's set. And if it's set, then we can ignore it. And we just want to go quote. So this is just creating some code. We'll take our buffer and we'll say fields stringify. And we'll stringify our f, our name rather. And then we'll pass in the name here. So that'll print out the name of the what is essentially the phantom data for this part of the field. And then on the other side, we'll quote again. And by the way, the quote macro, of course, creates our token streams. And so we'll say let's just call this enum. So this is stringify. Take our n again. And we can say if let n equals n, and actually this should be num. Call this. I don't want to keep having these variable collisions here, so I'm coming up with pretty ridiculous names here. So we'll have an A in it. All right. And then take and we'll go none as an option of our type. Let's see, we got a few errors here. All right. Okay, so I think what I need to do here, instead of using n, and then we'll use name. All right, hang on. Kind of got this all screwed up. Let's for collision purposes, we'll call this v name, the variant name, and we're gonna reuse that in here. That needs to come down here. There we go. So this should be, yeah. All right, that should work out. All right, and I can go ahead and move on to the next part. All right, and we want to take our, what did I call these? Patterns. Take our patterns vector and we'll push into it. And what was this? This was just v name, right? So the variant name, then we'll get our field names, which is just an. or no, get these field names. And I've got too many parentheses here. Kind of like that. So what that does is it essentially sets up our, well, it sets up everything so that all of the fields will be in our debug macro, and then we've got the logic for the actual debug call here. All right, so that's for that, and then we need the what did we call this? Bodies. Let's push into that, and this may get a little convoluted. All right. All right, so let's get the type name. And so this will be a new string so that we have the string type. And then we'll use the stringify macro on the diff name. And then need to add our 2 colons, and then we'll use stringify again on the variant name. And okay, and then we need to create our buffer. We'll use debug struct with our FMT formatter. We'll put in our type name, and then the generated code. We'll take our fields and just repeat them, and then we can call buff.finish. So basically, remember, we've got this logic here. So what's happening is we're taking this logic and we're just replacing it in here for each of the different fields. So depending on what the field looks like, whether or not we should ignore it or not, it'll have different debug logic. So that's essentially what this is doing. All right. So now let's work on the next case. So this is if we have a tuple struct. The variant is a tuple. So let's see. Actually outside of the match statement. Yeah, here we go. So tuple, then we'll get our vname and our v fields. Get our field types, and this would be a vector type. V fields, iterate over that. Collect these after, and TPY, yeah. So we get the types for each of our fields. Then we need, since it's a tuple, we don't have names, so we need to get the max count. So let's just call this field max. So this will be our field types dot length. And then we can create names. So that's what we're gonna do. So for this, what we'll do is we'll just use the index of the positional field. So field.max. So we'll take a range here, then we can map over it. And we'll map over it with our ident. So formats, let's format ident to create a new identity, and we'll just call it field like that, or do it like this. Ident there. All right. And then we want to collect this. All right. So that gives us all of our field names. And yeah, we should probably put a type annotation here. So this is a vector ident. What's the error here? All right. Oh, right. Need to get rid of these. So I actually have a return type. There we go. Then we need our buffer. And this is again an ident. Format idents. Call this buff again. Basically, when we create the ident like that for the buffer, it allows us to gain access to the buffer before we actually create the buffer in the code. So we can do things with it before we manipulate the code, and then we can insert those later. So this will return a token stream, and so we're going to take our v fields and we're going to iterate through them and then enumerate, then map. So this will have the index and then the field itself. And for this, we're going to end up collecting. So that. All right, so we get kind of long. So f name is going to be format ident. And again, we'll do it like that. All right, so we're retrieving the names that we created here for each field. And we need to get the type as well, so it should be d.type. And then we can match on our field.max. So if we have 1, then we can just quote an empty block of code. Then if we have more than 1, and if our field should ignore, meaning that's true, put quote here, that'll be easier. For this one, we'll have buff.field, put in our f name, and then for all other cases, comma there. And then for all other cases, I think this is a method called should ignore. You can say if let some field equals f name buff.field plus our field in here, else buff.field, and we'll say a reference to none as a option of our type, f type, like that. All right. Now again, we want to get our two vectors and start popping and pushing, or start pushing this stuff in there. And just grab these two like this. Alright, so for the patterns, this is a tuple, so it's slightly different. We want to get rid of these brackets, instead have parentheses. So the format of our type will be completely different in this case. And then let's see. Did I call them field names? Like that. Alright, so then for the bodies, we again have a slightly different setup here. We're going to match on the maximum amount again. If we have just one field, then we'll go get the type name, or rather create a type name using a string. This diff for that, and then we need our colons. This is basically what we had up here. We're just recreating the type right here. We'll just copy that over. All right. And then we can have a if let if we have a field, this is going to be 0 field 0. Remember, this is code that doesn't execute when we're creating the actual, or when we execute the proc macro itself. This is code that executes in the user's application. So let's use the write macro here. We're going to write with our formatter, which we'll supply in the function body, and set up how we want it to look. It'll be type name, and then the field that, and then otherwise we'll say this is if the field is none. And this is kind of a hack, by the way, to do it like this, to cast the option into a option of a unit type like that. It does help, though. It makes this so much easier than trying to work with the other type. Alright, so again, we'll have the type name and then the field like that. Alright. So that's for case 1. For all the other cases, we can grab this piece again. And then we can just say let mute buff equals f.debug tuple, pass in our type name, and then we'll have our fields. We need to have 0 or more of them, and then buff.finish. Alright, so that looks good. And now we have our final case. Before I do that, let me see if you guys are talking in the chat. So we have a few people. Some people saying hi, and a lot of people are lost, it seems. Sorry guys, I know jumping into the middle of a library like this is a little hard. I do plan to make a tutorial on proc macros at some point in the near future, especially since I've just been writing this really long library. All the concepts are really fresh in my mind. So if you are really lost, look out for that in the future. May help quite a bit. All right, so now we just need to set up another case, one more case, this time for the unit struct. So unit struct, of course, is if we had like an enum, say test, we have various different types that could be in here. You could have a type A, which is a struct type. Say it has like a field A, which is usize. So that's our first case. Then we have a tuple where it looks like this. So again, we have like a string in this. And then we have our last case where we just have the value, which is the unit value, so C. And what we're essentially doing is deriving the debug trait on it. So we want to be able to print these out in a specific way, depending on what type we've got. So we've done the struct, then we did the tuple here, and now we're going to do the unit field. All right. Hopefully that makes a little bit more sense. Is Rust the future? It is and it isn't in some ways. All right. So let's see. I think this is the match statement here. So we have struct. It's S variance units. Then we get our variant name. Let's just call this v name. And then the v fields. And in this case, we're not going to need the v fields because there won't be any. Remember, it's just a unit. And for this, we can actually skip a lot of the other setup that we did here and instead just push into these two vectors. Whoops. I did not mean to do that. All right, so for this one, let's get rid of all this. Remember, it's a unit, so it's just going to be self and then the variant name. And then for the next piece, we don't need all this matching and stuff. Get rid of that. And this. And that. Actually, let's use this bottom part. You need that. You need a quote. That. Anyway, so we have our type name, which is again is going to be the same. And then we want to call debug struct, not debug tuple. And then we can call finish. And we can get rid of this piece here. We don't need the actual buffer. All right. Good, good, good. There seems to be an error somewhere. Oh, right. It's because the function isn't returning the token stream yet. This is a really long function, and after I finish making all the logic, I plan to break it apart and refactor all the functions. In fact, you look at my struct functions, they're really damn long. I think one of them is almost 100 lines of code, which is kind of insane. This one here, the one that implements the diff trait, like 100 lines of code, or no, it's more than 100 lines. It's like 200 lines. So yeah, I need to break that apart. All right, so now let's create the body of our code. So remember, we were just really doing the inners. So we'll have a match self, so match on the diff enum type, and then what did we call them? We called them patterns and bodies, right? So we want to get the patterns, and we'll put them as cases against the bodies like that. And we can have 0 or more of these. And yeah, so that'll be good. And then we need to surround this with an implementation block. So what did I call this? I think it's param dex. Yeah, param declarations. So these are like the parts that change the, if we have like generics or lifetimes or constants, stuff like that. So this is standard FMT debug that we're implementing for our diff, which is the name of the diff, which will be the name of the diff type. And then we have the params, which I think I just called params. Yeah, params here. Grab these. All right. And then we have our clause, which is our where clause. So if you have like a guard on an implementation block, it'll be like where, and then you use like the generic, for instance, to implement like traits and stuff like that. So that's essentially what I'm doing there. And then we'll have our FMT function, which we need to implement for this trait. So this has self, and then the formatter, which we've used multiple times already, in which we're going to call f. So standard FMT formatter. And then we have standard FMT result. And then for this, we're just going to return the body. We just put the body in here. So that's this entire block. Just goes right in here. And then, of course, depending on the way that the enum looks, it could be some of these other ones that we've quoted off. Remember, code that's quoted off doesn't execute until it gets generated and all that. All right, so we still have an error here. This should resolve the error because we're returning a token stream now. Looks like it did, but there still seems to be another error. Let's see. Kind of shared reference. Maybe I do need to use a for loop here. Right, so for var in e variants. Like that. And I'll wrap all of this into, no, I don't think, there we go. Did that fix our problem? No, it didn't. Okay. So, to resolve this, all right, because I need to call iter Let me check real quick. I guess I could just call clone on it. I don't especially want to do that, but it's fine for now. All right. So now that we've got that, we've got literally one more function to implement, but this is the long one. If you remember in the struct implementation, the one that was 400 lines of code is the one that we're about to implement, which is the function that implements the diff trait on the type. So that's what we're going to do with our enum. So let's call this implement diff enum. And like with our other function, it's going to take in an input model and then output a token stream. Right, and then we've got a bunch of setup we need to do. Let's go up here and grab a few things. Some of these. Excuse me. All right. Trying to think. There may be a better way to do this. And I may want to go and implement some new methods on the input method or input model. Got a few on here already, so maybe I can just work with those. Some of these are unimplemented. Oh, right, these are the ones we're writing. Dir. Speaking of which, might as well hook some of these in. So we've got derive diff enum, and then we've got derive debug or implement debug enum. So up here. Implement debug like that. And now we can grab these, copy these. Go all the way up here, import them. Like that. We can just add them here where we have unimplemented. So implement debug, the self enum, input enum. Is it implement debug enum, right? Then for the derived diff, it should just be what did I call it? Derived diff enum. Yeah. Like that. And so now the final one we're going to set up is this one here. Implement diff enum. All right. Just to get rid of this, just call quote. So we are returning a token stream. All right. So let me get a few more fields. We're going to need the name. So we got the diff. Got the E variants. We have the param declarations, and we have the type params, or we have the params themselves. We also need our clause. So this is like the where clause of the enum if there is one. So input dot clause. And then we need to modify our param declarations. Let's redefine that. We'll turn this into a vector of token stream. And this we'll just say we want to iterate on this. We'll map on it. Let's call this PMS. So we're going to match on that. And in fact, I can go and copy some of the logic I have up here. Really don't like using PMS. I'll just use P. Let me just copy all this. I'll explain what's going on here. All right. So we're going through the param declarations, and we need to determine whether or not it's a lifetime, a constant, or like a generic type, and then we need to do different things depending on what's going on. So that's what this is. So we're using this generic param enum to do it, and I think there are more types attached to it. Oh no, it's just type, lifetime, and constant. And so we can match on that, and then we can define how we want to generate our code. So the lifetime and the constant one looks fine. This one, we need a few more traits to be implemented by default. So we're going to need debug. We're also going to need partial EQ. Already got identity diff. Let's see, what else do we need? I think, in fact, I've actually got this in here. Let me just copy that over. It'll be so much easier. All right, so we got clone, default, diff, debug, partial EQ, serialize, and deserialize. By the way, you guys may or may not have seen this kind of for keyword before. What this essentially is it allows us to specify a lifetime. So this trait needs a lifetime, and it'd be a real pain to have to specify a lifetime for our enum type that we're deriving this on top of. And so instead we've got this for keyword that we can use to basically say, all right, we want to define a lifetime and then put it into the trait. So that's essentially what we're doing here. So it doesn't get messy. All right. And then of course we've got the bounds, which we're creating here. We're adding them. So if the user is implementing more traits on top of it, those would go there as well. All right. So now let's move on to our predicates. Call them preds. This is again a vector of token stream. And we're getting our clause. We want to iterate through it. Let's see. And inside of it, we're just going to go quote. And we're going to take the thing that we've unwrapped here, CL. I'm just going to unwrap it like that. And this should be brackets, not parentheses. And then we can go even further. Just say let clause equals quote. And we need to add our where keyword. And we need to account for multiple predicates. So pred. That, we'll have a comma, and then we'll have our star. It means one or more. It's like regex, regular expressions. This should be preds. There you go. That's another thing. If you have iterators that you're working through inside of a quote block, it'll automatically iterate through them. So here we've got like a vector of token stream, so it turns it into an iterator, and then it can iterate through them using the syntax, which is nice. What's this about? What am I forgetting? I'm missing a step. Got the clause, da 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 da. Let's see what I did up here. I'll I did do the same thing. I should have just copied it over. Oh, right. Got to get the predicates. Can't iterate through the actual thing without touching the predicates. So, there we go. Alright, so that deals with our where block, or our where guard. And we've dealt with our bounds, our trait bounds. So now we want to, let's see. Let's set up our body. So I'm just gonna set up the basic structure of the code. So we'll have our param dex up here. And we're implementing identity diff for, what do we call it? Just name. Gotta put our params in here. All right. And of course we need our clause. All right, so then the way that this is set up, and actually let me open the file where I've created this trait so you can see what it looks like. This is what the trait looks like. So it's just, it implements clone, debug, partial EQ, and then it's got a type. This is the diff type. So for instance, if you have a string, there's a special type that I created called diff string, which is our diff type. And basically it's an intermediate. It holds all the data to allow us to combine two strings together and make the new one. Then we've got 4 functions. We have diff, which takes 2 structs of the same type and then creates a diff type. And then we've got merge, which takes a struct and then a diff and then creates a new type based off of that diff. And then we got from diff, where we take a diff and we turn it into the type. And then we've got into diff, where we take our struct and then we convert it into a diff. All right, that's basically it. Not that complicated. At least I hope it's not that complicated. All right, so up here we'll implement our type. So diff is the name of our type. Diff is the name that we got here from here, the identifier. And this also has our params in it. All right. So now here's the fun part. Here's where things start to get complicated. We need to define the logic for our different functions, and this can get really complicated because we're going to need to do multiple bodies based off of the type of enum that we're putting in. So, excuse me. So, for instance, all right, let's do this. All right, so I'm going to keep this down here as the main body, and then what we'll do is we'll take whatever we create in the other one, we'll just pass it into here. So, and actually I could go ahead and just, oh, I didn't keep it open. Let's see. Go ahead and just grab these from here. Pass them in here, and I'll take all the bodies out for now. All right, and so what we're going to do is basically fill in these functions depending on the type of enum that we're working with. All right, so how do I want it? okay. Let's say let's get our diff patterns. So this will be a vector, vector of token stream. And again, this will be mutable like we did before, and then we'll have just have patterns. This will be normal patterns. And then we'll have our body, our bodies rather. So now we have 3 mutable vectors, and we may end up adding more later. So now we're going to again go through our enumeration vector, or enumeration variance. I don't know what an enumeration vector is. So var in e variance iter. And then again, we want to match. And I can actually reuse a lot of the code that we had up here. Let's just grab this. Then I can get all the cases as well. So here's one. Let's grab this one. And then the other one, all right, I can just copy this multiple times. Just change this to tuple and then unit. All right, so that fills out our match block, which is good. So now we can start working on actual logic. So all right, let's start with the merge function. This is the first piece of logic that we're going to work with. So get our f names. We want to be fields. Iter, map, and collect. All right, and I'm going to map again. So that we can create a identifier for the self side, meaning the enum that we're calling this method on. So this will be based off of the identifier, so it'll be self underscore and then whatever the name is. And then we can do it like that. Oh, this is just fields. It should be v fields though. All right. What's going on here? I could like that I mapped over it twice without specifying the types. I think, well, first of all, I don't want to do this for the f names. The f names are the f names. But for the self names, this won't be a reference to ident. So that should, I think, fix the problem. Yeah, all right. And then we have our diff names. Again, we'll map twice. Probably should have just copied the code, whatever. All right, there we go. And we also want to get the values of the fields. So this one's going to be a little bit more complicated. The fields. Use a zip instead. We can zip over our self names, and then we can zip over our diff names, and then we can map all of this together. So this would be a double tuple. Oops, accidentally popped up Discord. Double tuple with f, which is the field, and then say s, which is self. Let's just call it sn, and then dn, which is our diff name. And let's see, we want to collect this at the end. Sorry if you guys can hear my cat snoring. Anyway, all right, so if f dot should ignore, so if the field has been marked as something that we want to ignore, or the user wants to ignore, quote it, and we're just specifically going to use the s name, like that, and we probably are going to need to clone this thing. Otherwise, if let some diff equals dn, sn dot apply, or not merge, sn dot merge diff, again probably had to clone it, else, by the way, this is the function logic, so this is what the logic of our merge function is going to end up looking like. So sn clone. So if it's none, then we want to return self as it is, and if it's got a value in it, then we want to merge that value with the type that we're passing in. Why are we getting an error here? Don't especially like this. Something's missing. I'm missing something here. I screwed up my oh, forgot to call quote. Of course. There we go. All right, so now we can go ahead and get our vectors here. We'll start with our, you know what, I'm going to call this S. Let's just call this self pattern. So we have self patterns and diff patterns. That'll make more sense. So first let's start with self patterns. So go self dot name, which is the name of our, and it's vname that we want. So self of the variant name. And remember, these are structure type enums. So if the fields look like structs, then this is what they'll look like. So what do we call this? F names. And then we want to go with our self names. Like that. Then for diff patterns, we'll go self dot type vname f names. Oops, too many parentheses, and then self names again. Oh no, this time delta name, which diff names, which would be here, like that. Let me take a break here for a moment. My brain is actually hurting too, guys. Let me, I want to finish this last one and then I'll take a moment and I'll field some questions. If you guys have any questions, just feel free to throw them in the chat as I'm doing all this. I don't mind. Even if they're not Rust related, you can just ask any questions you have. Bodies. Push. Again, we'll quote. And we'll call self from diff. Diff. And we'll probably have to go diff.clone. Alrighty. So there we go. That's that first branch done for one of 4 functions. So this could end up being pretty large like the other one was. Alright, let's field some questions before I go a little bit insane here. So, what plugins do I have for VS Code? Says, I'm not even going to try to pronounce your name, but let's just say Alexandru for short. So I've got quite a lot of plugins on here, but I'm assuming you're talking about the Rust plugins. The main Rust plugin that I use is just this one, the rust-lang.rust plugin, which is pretty good. It's based off of the RLS extension, and it's actually pretty easy to set up, and it works really well out of the box. So yeah, this is the one I use. I don't use anything else for Rust, mainly because usually if you do try to do that, the different extensions will conflict. Though there are some pretty nice ones apparently that do complement the RLS behavior. I do occasionally use tab 9 as well. I have the beta for that, and I actually have a pro key for it. Whoops, didn't mean to do that, guys. But yeah, so yeah, I have a tab 9 pro key, and occasionally I use that. If you don't know what tab 9 is, it's basically a machine learning algorithm that allows you to do auto-completion, which is, it's alright. It's better for some languages than others. I find that it's fairly decent for Rust and Go, but not so great for Dart and other languages like that, especially since Dart already has its own machine learning auto-completion algorithm in it. So yeah, if you didn't know that, now you do. Anyway, also for my theme, because inevitably somebody's going to ask this, the theme I use is Spacemax Dark, and the font I've been using is Code with font ligatures. That's why you get arrows like this and stuff like that, or code ligatures enabled. There's another font that I'm thinking about changing to as well, which is actually a Microsoft font that they just created, which is really nice, called Cascadia Code, I think. And yeah, I'm liking that, so I might well, I'm not going to do it now, but I might try it at some point. I use it in my terminal. All right, so next question is from Alpha Salan. Hope I'm not destroying your name. Sorry, man. What vape device am I using? I actually just got a new one called a Aegis X. I actually quite like it. Normally I do dripping, but I just got myself a tank because I found that I really don't want to carry around a lot of bottles of nicotine liquid. So, yeah. I just decided to finally get a temperature control tank in a new mod. Anyway, I know a lot of you guys are not interested in that, but I just want to answer the question. Oh, nice, man. You also use an Aegis. That's good. I just did a bunch of research, and it's been a while since I bought a mod. The last one I had was I had a mech mod, an old mech mod, and then I also have a what's it called? The hell are those things called? Now that I'm looking for it, I can't even find it because I put it away. Anyway, it doesn't matter. It's inconsequential. Alright, so then we have another name which is in Russian or some other Eastern European language, and I'm not even going to try to pronounce that either. Starts with an A, what looks like an N, and he asks what the asterisk at the end is about. So the asterisk, it's kind of like regular expressions. Asterisk denotes that you have one or zero or more items in there. So this essentially, if we look at this, for instance, this could repeat 0 or more times in the generated code if you put an asterisk behind it. So basically, if we just look at this one, for instance, it would look like self and then the name of the variant. So maybe it's like variant, and then make sure to comment all this out. And then inside you'd have the field. So you'd have field, say A, and then the type. So it'd be like usize, and then B, and so on. And if you had 0 fields in here, it would look like this. Then if you had multiple fields on here, you could have infinite, technically, with the asterisks. There's also a plus sign which you can use. So the plus sign is if you have 1 or more. So that just guarantees that there will be one of this pattern in the generated code. But in this case, we have cases where there won't be fields. And so that's why we're using the asterisks. So I hope that, I hope that answers your question. Yeah, vaping is kind of a life-saving thing. I used to smoke for like 10 years before I eventually quit. And that was almost almost 15 years ago now. Not 20 years. That'd be a long time. All right. All right, so I'm going to move on to tuple and unit for the merge function. And I think I may stop after that. At least stop the stream. I'm probably going to finish this thing tonight. But if I do end up finishing it off stream, whenever I do my next stream next week, I'll make sure to go through the code so you guys can see what ultimately came of this program. And I think this one I may post as a video, unlike the last stream. The last stream was just too disorganized. But this one is a little better. I mean, it's still disorganized because I'm starting in the middle of the development cycle, but I don't know. I feel like at least somebody who has a surface knowledge of proc macros might be able to get something out of it. If not, whatever, maybe somebody just wants to watch it. I know a few of you guys just enjoy listening to my voice drone on about certain things. So. Anyway. Alright, so this next part, it's actually much easier. Well, no, not really. But we can reuse a lot of our code. So let's copy some of this. Oops. So remember, tuples, we're not going to have as many names and stuff, obviously, because tuples don't have named items. But anyway, I'll put all that in there, and then we'll go and we'll modify the code as we go. So let's start at the top. Really, we're not looking for names. We're actually looking for types instead. So this will be f.tpy. This should be b, by the way. Just so that I don't have that problem after, I'll put a v there as well. Alright, so that gives us our type, and I'll call this f-type and tpy. By the way, the reason why I don't type out tpye is because it's a keyword in Rust, and it's a pain in the butt to use that. So like if you have like a var type, it'll throw a fit about it. There is one way to get around it though. You use a r and then a pound sign, but with macros, since we are using the pound sign so much, I don't really want to do that. Anyway, so that's just the thing. The other part here is, anyway, so the next part here is we want to get our max again. So let's just call this fmax. So the maximum position, or the length of our struct, or rather the length of the tuple essentially. So f types, and this should be types, not type. There are multiple of them. And I'm just going to get the length of that. And then we'll create our self names. And for this, instead of going v fields, we can just go 0 ... fmax. Get rid of the iter here. And then for creating the actual name, do that. And thing is, so this is not a field anymore. This is identifier, so we don't have to double map over this. Instead, we just have the identifier immediately, and then we can just do a format idents to create a new identifier, and we can do self underscore like that, and then we can use the ident. So this will be like self1, self2, and so on. Alright, so then we can do the same for the diff, except we'll use diff instead of self. Here, like that. Change this to diff. And then for our values, we again are still going through v fields. This time we're still zipping everything, though this time we need to add .iter. And then we still have our same structure here where we're mapping. We have the f, which is the field. Then we have the self name and then the diff name. And actually, in this case, this is the data field. So again, if we have should ignore, if the field is should ignore, then we'll just do what we did last time. And then if it's not, not. I think we can just do what we did last time as well for that. That really doesn't change at all. The next part, though, is of course going to change because we don't have struct type. Instead, we have tuple types. So these are not brackets, but instead parentheses. And so we have self vname, and then we are going to have, instead of f names, we'll just have our self names in here, and yeah, we'll just do it like that. Then for the next one, we'll do the same, but with diff names, like this. And then for the final one, we'll use the field values. So, and for this, instead of doing from diff, we'll just do self vname field types, or no, f values is the one we want. All right. Cool. All right. I think we also want to push in a couple other things. So self patterns, we're pushing in this. We've got a, essentially what we're doing is we're building a pattern matching block. So we need to add another part to the pattern here that catches any fields that we don't add here. So self patterns, and of course we can just use an underscore. So we'll just use quote underscore like that. So after we iterate through all of the self names and we add them to the pattern matching block, we can then just have our underscore to catch everything else. Then for diff, we want to go quote. So remember, this is the, so self is the pattern of the pattern match, and then diff is the body of that pattern. So it'll be like, so it'll be like self patterns, and then a fat arrow, and then diff patterns, like that. All right, anyway. So then here we can go diff at self dot type dot vname, and then we can put dot dot in there. And what that essentially does is it catches everything at the end, and it puts it into a var called diff. So it basically completes our pattern. Okay. All right, then match. And then for our bodies, oh yeah, and by the way, so I actually got that explanation wrong. The self patterns and the diff patterns are the things on the left side. So it'll be like self patterns, and then diff patterns, and then we'll have our bodies on the right side. So it'll look like this. That's what we're essentially building. All right. So then the final thing we want to do for the bodies part is just push the case for a match that matches everything, which will just be self from diff diff.clone, like that. All right, that just deals with any cases that we miss. Now we can do the unit struct, which is actually pretty simple compared to the other ones, at least. Again, though, probably let's copy this part. This is the part that we need. All right, so we have our self patterns, or self patterns, yes. And remember, these are unit, so of course they don't have anything in them. Again, we can do the same here. And of course, this here. Let's see. Oh, that's looking decent. Yeah, that's looking good. All right, so that's actually it. That's all we have to do for that part. That fills out the merge part. Now we can add the actual body for the merge function. So inside of merge here, we can now go ahead and just say match self, then diff, and we can open this up and we can put in our what's it called, our self patterns first. Then the diff patterns, and then we want to get our bodies that, and just to be safe, let's put them in some curly brackets like that, put a comma, and then of course we're going to need a asterisk. Just so that you guys know why I did things like this, let me open one of the files for implementing this trait, and I'll show you what's going on. So if we look here, I'm implementing this trait on the option type, and if we look at the merge here, notice this is kind of like what we just did. So we matched on self and diff, and then we had two different patterns, and we took both of the different patterns and we matched all the different combinations to determine how we wanted to merge the data together. And that's basically what we just did. We have a case where there's none, and then diff option none, and some, and diff option, so on. So there are multiple cases that get combined together like that to create the merge functionality. Anyway, all right. So I think I'm gonna just stop it there. I may field a few more questions if you guys have any. It looks like everybody's still quiet, though I'm sure there's a delay. I'm gonna wait a few minutes here and see if you guys come up with anything you want to ask me before I stop. So by the way, I'm going to try and make this a weekly thing. EKAJ says no questions, thank you. Thank you guys for coming out here. I'm going to try and make this a weekly thing so that you guys can see the type of stuff that I'm working on. And I'm also going to try and start working on more tutorial-based videos when I actually have some time. So hopefully I'll be able to get at least one a week, I'm hoping. And if possible, maybe two. Those will be on multiple different topics. Right now, I'm doing Rust mainly for the live streams because that's what I'm working on. But if I come to a point where I don't have a lot of work on the project that I'm working on, maybe there's like something blocking me, I'll do something else. All right, so Greg Goriz. Sorry, man, I'm going to butcher your name. I'm going to butcher everybody's names, so just kind of assume that. Do you have some experience with Rust for embedded? Yeah, I do, actually. Do I have any thoughts on where you should start? Well, I recommend looking at Xcargo, I think it's called. Is one thing to look at. Let's see. I think it's Xcargo. There's a nice book, too, on embedded devices for Rust that you can look at. You just Google Rust embedded, you'll look into, it'll talk about things like no standard, how to create functions without mangling them, how to create like kernels and stuff like that, make virtual machines, call to hardware without the standard library, and stuff like that. And actually my last project that I did for IOTA was technically embedded. Stronghold, which was just a very basic database. And yeah, I'm not sure if I can say this, but I will anyway. They are kicking around potentially putting it on in cars and on credit cards and stuff like that. So yeah, it's the definition of embedded. Of course, they will have to make implementations that implement no standard, which means there's no standard runtime built into the code. You have to make your own. So even Rust has a very minimal runtime, but if you implement no standard, then you get rid of the runtime. And yeah, there are various reasons why you would do that for embedded systems. Anyway, so yeah, I recommend looking at the embedded book. Like I said, you can just Google it and you'll find it. That'll really give you a good start. And if you have any more questions, you can always hop in next week or something and ask again. So let's see. A lot of people just giving thanks and love. That's great, guys. I love my community. You guys are great. Motion. I think that may be the only name that I didn't butcher, though. Probably did in some way. So he says, would love some more content on Phoenix and Elixir if you have some time. Yes, I've been meaning to do some Elixir for a long time, and I'm hoping that I can get around to doing a few videos in the next few weeks, potentially. So, I know Elixir's not my most popular series, but it's one of my favorite technologies, just objectively, so I'll never give up on doing tutorials for it. So you can rest assured that there will eventually be some Elixir or Phoenix content, or both. It's just a matter of when I actually get some time. Alright guys, well I'm going to close it here, but I think I'm going to post this video on the channel, so if anybody wants to see it later, or needs to reference something, you can go ahead and do so. Thanks for coming out as always, and I hope to see you guys next week or in the next video, whenever that may be. Have a good evening or morning or afternoon wherever you are.